Bismillah ar-Rahman ar-Rahim. Welcome to Lady Khadija radiallahu anha online college. May God be pleased with her. Live lesson A-level math. Today it's an introduction to the concept of radians when it comes to measuring angles. So let's begin. If you're following through in the book, it's chapter 5. Okay, Bismillah ar-Rahman ar-Rahim. In the name of God, the most gracious, the most merciful. Let's start with a nice neat circle. And before we discuss angles, let's talk about the circumference of this circle. The circumference of a circle, you should hopefully remember the formula is 2 times pi times r. Let's just write in the pi. And the question is, if the radius was, just to keep it simple, let's say the radius was just 1, then what would the circumference be? And hopefully you'll see that it's just 2 times pi times 1. And we don't really need the times 1 at the end, so it'll just be 2 pi. So that means that the circumference, the distance all the way around this circle, would be equal to 2 pi. Okay, the whole chapter is not about circumference of a circle. The chapter is about a new method of measuring angles. So let's go back to the circle, but this time let's take a look at the angle that we have. So hopefully you remember that the angle for a full circle is 360 degrees. So that means I can take a line from the center of the circle, and if I take that line and I go all the way around the circle, then the angle that I'm making is 360 degrees. But the thing you need to try and get your head around is that this 360 degrees, it didn't always have to be 360. The number didn't have to be 360. You have to imagine that somebody's just made that up, or a group of mathematicians just made that up one day, and they all agreed, okay, let's make it 360 degrees so that we can split this circle, this turn, this full turn, this circle into 360 parts. And we can say that if we're going from one part to another, then that's 1 degree. And in total, it takes 360 of them to get all the way around the circle. But it didn't have to be that way. We could, instead of doing 360, we could think of another number. We could go with maybe 10. 10 would be much simpler. Maybe if you want a bigger number, you could have gone with 20. Or if you wanted a smaller number, you could have gone with maybe 6 or 7. You didn't have to go all the way up to 360. So if we're choosing a smaller number, then let's choose a smaller number. What's wrong with 10? 10 would be a pretty good number. Make this circle into 10 parts. We couldn't then call it 10 degrees. You can change the word. We can change it to 10 bits or 10 parts if we wanted, or think of a new word. Let's think of radians or something like that. But is 10 really the best number? I want you to imagine that somebody, a very clever mathematician, he decided, look, let's go for a small number, but let's go for 2 pi as the number of parts we're going to divide this circle into. Why 2 pi? Because we saw earlier that if we have a circle with a radius of 1, then the circumference becomes 2 pi. So we could divide this into how many pieces? Not 360, not 10, not 5 or 15, but we could divide it into 2 pi pieces. So we could say that going all the way around the circle, so let's say I bring back the line. So making an angle that goes all the way around the circle, we could say that's 2 pi. We could say that we're splitting the circle into 2 pi pieces. Remember, pi is about 3.14, so we're splitting the circle into 2 times 3.14. So that's about 6 or 7 pieces we're splitting the circle into. So we'd say that each piece then is one piece. We'd have a part of a piece just at the end. But if these were equal pieces, then we'd say these are 1, 2, 3, 4, 5, 6, 6 and a bit. So that's two pi pieces. But the word pieces isn't really gonna help us. It can get confused with many other things. So let's give it a name. Degrees was a really nice word. Everybody got to know what degrees actually meant. It meant that if you had the circle split into 360 bits, then one of those bits is a degree. So now we're splitting the circle into 2 pi pieces. Let's call each piece a radian. So we've got 1 radian, which is the angle from the black line to the first red line. And then we've got another radian, the third radian, the fourth radian, the fifth radian. To get all the way back to the beginning, I need 6 and a bit radians, or exactly 2 pi radians. Let's take the red lines off. Let's stick with the word radians. So the question is that if we've got this new way of measuring an angle as radians, then let's start off with the basic, that to go all the way round and form a complete angle of what used to be called 360 degrees, if we go all the way around now, we're going to call that full angle 2 pi radians. What about going halfway then? What about if I did an angle which went just halfway around the circle? What's that angle now in my new unit of radians? That would be just half of what the full circle is. So if the full circle is 2 pi radians, then half of the circle would be pi radians. And remember, that used to be 180 degrees. Okay, one for you now. Try to type it into the chat box if you can figure this out. So under the old under the old way of measuring, that was a right angle and that was 90 degrees. Well, with my new way of measuring the angle as a full circle being 2 pi radians, then how big is this angle here? Give you a few seconds to think about it. Okay, well, let's think about that. It's just a quarter of the circle. So if the full circle is 2 pi, then this is just going to be the 2 pi, but a quarter of it divided by 4. Cancel out the 2 and the 4 to just 1 over 2, and that becomes pi over 2 radians. It does get easier, but you just have to give yourself a day or two to get used to it. Get used to it. Up until then, you want to remember how to change from one to another, and it's all to do with the 360 and the 2 pi. So let's say we have an angle which is not as easy as the ones I've given you, but let's say I had, let's say 40 degrees in the old way of looking at angles. If I want to change that into radians, then all I have to do is times by, you just have to, it's a fraction. On the bottom of the fraction is a very easy familiar number, 360. That's because a full circle is always, used to be 360 degrees, and it will still be 360 degrees if you're measuring in degrees. And on the top of the fraction is 2 pi, because 2 pi is the full angle. So if you type that into your calculator, whatever answer you get, that's the answer for the number of radians that 40 degrees is. You've just changed 40 degrees into radians. I'll let you do that and then type that in. Okay, and while you're doing that, think about the next one, which is what if we want to go the other way? So let's say I've got 1 radian, and you'll see the symbol for radian is just a little bit like the degree, but it's just half of it. It's just like a little C there. So what about 1 radian? How can what if I want to change that to degrees then? What would that be? Well, to change, I just do the same thing. I just times by a fraction. So I take the 1 and I times it by a fraction. This time I've got radians and I want degrees. So at the top of the fraction, you'll have your degrees number. Whatever you want goes at the top, and on the bottom you'll have the other, which is the 2 pi now. So on the fraction, you always have 2 pi and 360, and you're just timesing by the fraction. And if you want to change into radians, you'll use 2 pi at the top. If you want to change into degrees number at the top, which is 360. So if we do 1 times 360 over 2 pi, that'll tell us how many degrees is 1 radian. And I'll let you do that. Let's take a look for the answer for the 40 degrees. No, it's not 180 for 1 radian. One pi would be 180 degrees. 2 pi is 360 degrees. So let me just show you what 1 radian looks like. Remember, what I'm doing now is instead of dividing the circle into 360 parts, I'm dividing it into roughly about six and a bit parts. So it'll be something like that's 1 radian. That's your second radian. That's another radian. So they're equal parts, and it'll take 6 and a bit of them to just cover the full circle. So that's your other radian, and then what I'll have is I'll just have a little bit left over. So that each one of these segments is called sectors is called a radian. So you can see that one of them is not 180 degrees. So so one of them is how many degrees?